Yep, we can see it just fine.
Cool. So yeah, and we work on privacy infrastructure. And on a high level, of course, security is important, because without security, all of this is broken and does not work. But to me, if we zoom out a little bit, what are we actually doing here, right? We're actually coming at this decentralized technologies not to make something a little bit more efficient, not to make, some Ponzi games a little bit more fun. In my mind, crypto and the larger motivation of the Web3 space is resilience. It is to empower individuals who are facing not just strong other individuals, but who are facing ever more powerful for-profit corporations and nation states, which are, trying to invade the individual's sovereignty. And that's what crypto tries to solve. We try to start that by looking at money, thanks to Bitcoin, and people are more and more waking up that data sovereignty is a real thing. And privacy is an important underpinning motive here, not just about decentralization. So still, we all want to decentralize all the things, right? So decentralizing all the things means all the products and all the services that a bunch of gentlemen offer. So, for example, this guy would really be happy about decentralizing all the things and work with a permissionless infrastructure that allows him to operate in a way that doesn't have these super annoying privacy regulations in place that currently make his business real hard. Well, he's not alone, right? There's other people who really like to look you deeply in the eye and decentralize all the things to extend the technologies that they push forward in the world. It's not just tech providers, though, right, who are really interested in using their power to grow their empires out there. He looks real happy. And how about this gentleman? All of them are looking at decentralized technologies from a different angle than I do. And it is important to realize how we use the Web3 to make the Web3 a better place that is more resilient for individuals. And how do we protect us against the overarching powers of these gentlemen? Well, it is not just by decentralizing all the things, but it's by providing privacy infrastructure. And if we think about it, to me, there's a strong indication that there's something wrong in this on this quest to decentralize all the things. And this first indication is called MEV. We've seen over the past, year and a half, 2 years, how MEV is $1 billion opportunity. How we see $1 billion market growing that is based on bribing people to behave in a certain fashion that is deviating from what happened previously, which is deviating from kind of unspecified corners of a core protocol of Ethereum. And it shows that we can't corrupt the underlying infrastructure. Now, that's something we have to fix, but you might ask, how bad is that really? Well, the problem for me is that looking at the infrastructure that is underpinning all of this is not just the Ethereum mempool. Underpinning all of this, what we're doing here is peer-to-peer infrastructure. And the peer-to-peer infrastructure is at risk of harvesting individual user data in a fashion that is much worse than just today's MEV that we see. So disregarding if we're talking about Ethereum, infrastructure such as IPFS, the Graph, Pocket, or other chains, they all run on peer-to-peer technologies. And peer-to-peer networks are building on typically TCP/IP of the existing internet. And that exposes at least your IP address, but practically speaking, also a lot of other metadata that reveal what you're doing, who you are, and allows an observer to tie these observations to other accounts, activities, and things that you do in the Web3 wonderland. So on the one hand, we have a strong notion of anonymity, right? We have all these anon users who are rightfully making use of the human right of privacy as they explore the Web3. On the other hand, we have infrastructure that is at least on the most fundamental, on the most bottom layer of the stack, on the data transport infrastructure, not private, and that's an issue. So many times people say, hey, I don't really care if these large providers such as Infura, many of you have seen this outcry when last year Thanksgiving Infura upgraded their terms and conditions along with MetaMask to say, of course, we harvest and store your IP address. And people saying, hey, I have nothing to hide. Well, let them have my IP address. And I think this is a bigger issue than most people think. It is not just about some entity that collects your IP address. It is about linkability. I bet anyone who's listening to this does not just have one Ethereum address, right? You have a bunch of them. Some of them might be tied to things that are kind of natively doxed, such as an ENS domain, which might reveal your name, or a POAP, which is a real cool thing to collect on crypto conference. I like POAPs. But at the same time, POAPs is something that's tied to your face, right? There's been at least a bunch of people who know that you collected this POAP at this point in time, and it can be tied to your face. Do you really want to connect that one to your savings account, to your DGen account, to like whatever the hell you happen to be doing on chain? And I think that is a much bigger problem. Linkability of accounts that otherwise did not interact on chain is a pretty serious issue. So there's services like Chainalysis that try to go to great lengths to analyze what happens on chain. But there's this entire other infrastructure that leverages IP information, connection information to link accounts that otherwise look unlinked from one another. Now, that sounds a little abstract. So I want to do a little practical demonstration of how bad this is really. So we made a little tool called DERP. It stands for Dumb Ethereum RPC Provider, and I'll show in a second why it's actually a little dumb. So I'm going to make this a tad bigger. This is derp.hoppernet.org. I invite you to play along with me as I demo this tool. You can do it at your own pace. It works basically with any Ethereum wallet. So what DERP is really, it's a provider, it's an RPC provider that echoes all the requests that the RPC provider sees back to you. So basically, you see everything that your RPC provider also sees about you. So I hit that setup button. I have a MetaMask wallet. Let me see if it's unlocked. Yeah, it's unlocked. I have an account which, at least on mainnet, has no funds on it. By the way, can you guys see my MetaMask pop up? Sometimes I share my screen and you can't see my MetaMask, but I want you to see my MetaMask even if it doxes my address. Can you see my MetaMask pop up, which is open on my screen right now? Okay, excellent. Thanks for the info. So you can use DERP on a bunch of networks. We configured them for all of these. I'm going to use it on Gnosis Chain. Just because I know I have some funds on Gnosis Chain, it's cheap and reliable to experiment. So I'm just going to hit that switch button, which will add the network to my MetaMask. Let's see if that works. Of course, when I demo stuff, it doesn't work. It's the MetaMask tension effect. Okay, otherwise I have to manually add it. 1 sec. So I'm going to the new version of MetaMask, which is not what I used to have, and I will edit the DERP endpoint manually. So add network manually. It's DERP Gnosis Chain. Again, usually it should work by just clicking the button. I don't know why it doesn't right now. I copy the RPC endpoint. Chain ID for Gnosis Chain is 100. It's XDAI. The rest really is optional. All right, and before I actually edit, we can scroll down here to on the page. Just reload the page. And what you see is like there's a bunch of data that Derp will try to load. So far, it doesn't know me, right? So the RPC provider that I'm connected to, I'm not connected to it yet, so it doesn't see anything about me. So I'm saving this provider to my MetaMask. I do not yet switch to the network. So what is kind of interesting now is you see how this information here got populated, right? So I got docs right now. I'm sitting in Vancouver in Canada. That's my IP address. And in fact, you see that a bunch of requests were already being made, right? So reminder, I did not switch my network yet, right? So you can clearly see in my MetaMask, it asks me, do you want to switch to Derp Gnosis chain? I say, no, I don't want to do that, right? So, okay, it actually did switch me already. So that's why it did make requests. So the second I enter a network in MetaMask, it's making some requests. So even before it kind of doxes my wallet address, you see already that a bunch of information, which is kind of obvious to the technically inclined people here, but still it reveals a bunch of things. Even when doing benign looking things like just net version or ETH block number, an observer can find out that this address is right now having an Ethereum wallet. You can learn more about me, right? You can see that I'm on some Linux machine. You can see what sort of browser I'm using. So yeah, you already learned a whole bunch of things about me that you as an RPC provider have absolutely no necessity of actually knowing. And to make matters worse, like as soon as I edited, this was also doing an ETH get balance, right? Which loads my Ethereum balance. So it shows me my ETH balance for a wallet that's obviously kind of important. So it made that call. So, and from that point forward, now this IP address is tied to this address, right? So you can clearly see we highlighted it here whenever you have an address. This is kind of clearly linked. And just to be really sure, MetaMask is kind of polling this ETH get balance every couple of seconds. So at 23:52. And yeah, so it seems like every 30 seconds it's pulling the balance. So even if you were to use a VPN, this thing would keep pulling. So yeah, that's already a first pretty interesting lesson learned, that even if you were to use a VPN doesn't actually provide you so much privacy. Why? Because you have to think about privacy in terms of an anonymity set. What is the anonymity set of using a VPN? And a VPN is a provider, and we are not all using the same VPN provider. You're using one, I'm using a different one. Even among these VPN providers, you have to ask yourself, well, how many people are using that very VPN server? Right? Okay, that's probably not many people. And how many people are using from that exact same VPN server MetaMask? Well, probably you're alone at that moment, right? So probably you have an anonymity set of 1. And to make matters worse, the RPC provider can still identify you by your user agent. So how many users are using a VPN at this moment in time with MetaMask with this user agent? I'm quite certain no matter what VPN you're using, you are by yourself. Your anonymity set is 1, and in terms of account linkability, I can identify you pretty easily. So just something to think about when you think you're an anon, something to think about when you are interfacing dApps that you don't want to know anything. Think about that RPC provider. Okay, so far again, I didn't really do anything. What gets interesting is what happens when I add a second account, right? Again, I mentioned how many here have just one account? Probably nobody, right? All of us have more than one account. Let me add a second account here. So this is my Gen2 accounts. And again, the second I edit it, you see already a pop-up here. So this Derp tool informs you, oh, okay, I've seen a second address of yours. Let me just scroll down to the latest requests. And we see indeed it's pulling the balances from this second account. And even if you use a VPN, these are tied to the same address. And if you look at the timing information here, so this request has been sent like 5 milliseconds after the first one, right? So it really doesn't need any AI tooling. It really doesn't need any fanciness to understand that a request that comes 5 milliseconds after one from a different address that comes from the same IP address belongs to the same user, right? So this address and this address are both very easily linked by metadata information to be the same, to have kind of the same user managing it, even if you stay totally private, they're not connected in any way, they were active on different times of the day, you've been using Tornado Cache or other privacy tools to keep them entirely separate. And again, this information is visible to RPC providers. Just because it's kind of interesting, I will, like you can see different wallets doing different things here, like what actually happens when you interface a dApp, right? So this is something that I find quite educational on derp. So I'll just show here a quick example of app.uniswap.org. And as soon as so close this MetaMask. So far, not much happened because it's not been connected yet, right? So MetaMask is every 30 seconds just pulling my balance. I'm not going to go on Uniswap because that's not on Gnosis chain. I'm going to go to SushiSwap. Enter the app. And I'm going to switch over. Well, that's a bunch of chains. And I'm going to connect my wallet. Connecting my account. And so far not much interesting stuff happened because it just checked my balance. So okay, it knows what balance I have. I'm gonna switch one XDAI to, let's say, it's gonna HOPR is not listed on this one. Well, whatever. I'm gonna take some GNO. In the swap, what is kind of interesting is I have not yet swapped, right? So I'm about to make a transaction. So my wallet is querying the gas price here. Let's see what happened on derp. What is pretty interesting is this ETH estimate gas. So again, there's not much surprising things here for the technically inclined folks. This is just checking, hey, how much gas do I have to pay, right? But if you think about it, this is disclosing exactly what you're going to do before you actually signed the transaction, right? So this transaction is A, not signed, and B, it's obviously also not in the mempool. Yet there's a privileged individual centralized party that has access to this information, which is my RPC provider. So my RPC provider sees that I'm going to swap on Uniswap, and it sees from which address I'm doing that. You can find out what function I'm calling here. For the ones who haven't used it yet, a really useful tool is this 4-byte directory. You can just paste these function signatures, the first 4-byte that you see in a function call, so the first 10 characters, including the 0x. And yeah, you see that this one is a function call that's called process root, and this is the encoding of that information. So you see the sender address and probably the recipient address and a bunch of other things. I'm not exactly sure how SushiSwap works under the hood in depth, but all the information of the sending and receiving token and the amounts are in here. So at this point, I am trusting the RPC provider to not use that information against me, right? So I'm trusting the RPC provider to not front run me at this point, because this information is something that can be used to front run the mempool, right? Of course, you could say, well, that information is something which is not guaranteed to happen, so it's not actually an intent yet, right? I didn't sign absolutely anything, but it discloses an intent that I might have. It very clearly indicates that I am on SushiSwap right now, and I'm considering doing a swap right now, and I already went this far to actually check the gas price. And remember how I said in the beginning that I think if we don't really watch out, the Web3 is going to be a worse place than the Web 2.0. Well, what happens if we actually decentralize RPC providers? I'm all up for decentralization of power. I'm all up for disintermediation of central players who are in an unfair advantage compared to everyone else. Well, the problem here is that imagine we had a fully decentralized RPC provider. By the way, there is no such thing as a properly fully decentralized RPC provider to this at this point in time, but many people are working on it. So you would trust a random guy on the internet who you're currently connected to not use this information against you. Yet we see that MEV is a billion-dollar game where people, play whatever crazy games to get an information advantage over other searchers in this billion-dollar game to have a slight advantage. So to me, it's absolutely crystal clear that the information that a decentralized RPC provider would have can be used against you. And again, you cannot be certain that this has been sent from a right user, but if you have metadata information, such as the IP address, other accounts that they've just been using, you make that game way easier. So without decentralization, without privacy, decentralization in its most extreme form that many of us are targeting is not going to be a safe thing to do. So we need more privacy on that side. Right. Other questions this far? If there's questions, please do jump in anytime. Cool. So just to finish up this example, the ETH estimates gas has been sent. We see some ETH calls being made. I bet, quickly check this out on Gnosis Scan. What's actually going on that contract? Yeah, so this is the SushiSwap root processor. So I guess it's finding out the best root and it's finding out how many tokens I could get for something. Yeah, so a bunch of more calls being made. Afterwards, it's probably checking for updated prices or something like that. Yeah, it's all calling root processors after the call. Good. Okay, let me scroll to the bottom and then actually execute this trade. There's my MetaMask pop-up. I'm going to confirm the transaction. Of course, I have to click twice. I'm going to go back here. And finally, what we see is these ETH send raw transaction. So my actual raw transaction, again, before it was passed into the mempool, of course, did go through the RPC provider. So latest at this point, the RPC provider can actually be certain what's going on. They can they can do the usual games of front running or back running my transaction. But actually, they have all the time in the world to run sophisticated strategies, searching strategies on this transaction before passing it on to the mempool and have this privileged access. So this is, in my eyes, a pretty serious issue that we all need to address to make the crypto ecosystem safe for everyone. Good. Okay, so that was the first example to highlight how transport level privacy is important for privacy of individual Ethereum users. I'm going to bring you a second one, just because DeFi is kind of cool, but there's other people who don't find DeFi so cool, and they're into NFTs. NFTs is something very cool. You have funny pictures of monkeys and whatnot that people trade. What about privacy on that front? Well, one thing that I find somewhat unfortunate is how NFTs are actually storing metadata that are just served by centralized providers. And what we built here is what we call the non-private NFT minter. And what is showed here for demo purposes is this is an NFT, okay? What actually happens in the NFT is it loads an image. You can actually mint them and test this in your wallet. And the server is dynamically, so that the image is not a static like JPEG image, it is dynamically rendered. And this dynamic rendering encodes a bunch of metadata information that we found about you. Like in this case, again, I'm in Vancouver in Canada. It shows my IP address. It shows my preferred language in my browser. It shows my browser version. It shows my OS and processor architecture. So a damn lot of fingerprinting information that this hosting provider of that NFT can use against me, which isn't great, and it's kind of rough to provide a good solution for that in a centralized setting. So while doing that, we experimented with a bunch of wallets, and what we see some wallets. So first of all, NFT support in typical Ethereum wallets is pretty scarce. So I think MetaMask, at least in the desktop version, still does not support NFTs at all. And what some wallets do is they do server-side rendering of these images. So instead of letting your client request the image and render it, they do that from a server. So you would not see your IP address here when you load that in some wallets. You would see the server's IP address, which is a bit surprising. But if you see something weird, if you mint this NFT, that is because you've been you've been doing this on a wallet that is trying to protect your privacy. So I think this is just on mainnet. I don't have any funds on this wallet on mainnet, so I can't do this right now, but I encourage you to mint your non-private NFT, and you can send it around to different wallets, as it's always rendered client-side on demand if needed. You can load your NFT in different wallets and check out which wallets do server-side rendering and which one do kind of typical client-side rendering. So the ones that do typically show your IP address, at least last time I checked it, is Coinbase Wallet. So in Coinbase Wallet, the server will always see your IP address. Why does it matter? Because, well, I could send a funny NFT to Vitalik.eth, and if Vitalik.eth is active, he opens up his wallet that loads his NFTs and he looks at it. I can get a ping, and I know Vitalik is currently online. He has activated his wallet and so on. So there's a bunch of security concerns arising from that, which are pretty obvious, right? So it's not great that somebody can ping home whenever you have a wallet active. I think that's actually pretty messed up. So maybe, that's a silver lining for NFTs not being deeply integrated into typical Ethereum wallets just yet. All right, so that was the non-private NFT on this side. Cool. So let me go to the last section where I talk about how we're trying to fix that. So what we're working on at HOPR is privacy infrastructure to fix these issues that I just introduced. So if you want to be actually anonymous on the Web3, you can use the HOPR mixnet to interface Web3 infrastructure without revealing metadata about yourself, your connections, your wallets, make it linkable to others, and so on. How does it work? Instead of sending data from one party to another, in this case, we have like Alejandro sending data to Zoe. He's not doing so in a direct way because that would expose his IP address and other metadata. He's sending that through a decentralized network of nodes, in this case, HOPR nodes, which relay data packets. So these data packets are hopping around the network and thereby obfuscating where they came from and where they go to. That's where the name HOPR kind of comes from. So since we have multiple data packets that are hopping around this network at any given time, it's kind of hard to see where something originated from and where it goes to. Still, for the ones who are familiar with VPNs or with Tor, you might say, hey, this actually looks very much like Tor. Like, don't we have that already? Actually, as it turns out, Tor is not particularly private. So Tor is actually not metadata private, and if you have strong adversaries, they can follow these packets as they hop through the network and still figure out where something originated from and where it goes to. So we improve upon that by employing something that's called mixing, and that's why HOPR is also called a mixnet. So I'm now zooming in on one of these nodes that you've seen in the previous picture, and we see that this node operator is caching data packets for a short time and transforming them. So incoming and outgoing packets look different and indistinguishable from one another. And then this node operator is mixing them up, so they're sending them out in a different order than packets came in. And what it brings you is that an observer, such as your internet service provider, or anybody who's like peeking on your internet traffic, if you have a cloud node, that might be that cloud node hosting provider, they can see every packet coming into your router and every packet going out of your router. Even those guys cannot link incoming and outgoing traffic because of this indistinguishability of packets. So we're going to quite great lengths of making packets indistinguishable, especially in the header of a packet, which contains information such as where am I sending my data to, who's the next relayer, and so on. We do a bunch of tricks to keep that stuff private by using a packet format that's called Sphinx. It's not something that we invented, it's something that's been has been discussed in academic literature for a number of years, and is used by Bitcoin Lightning and a bunch of others. So we have a TypeScript and Rust implementation of the Sphinx packet format to provide privacy for mixnets like HOPR. Cool. So this is actually nice, but even that has been described by David Chaum over 30 years ago. So why have mixnets not taken off? Well, for one, mixnets are kind of slow. So you need decently fast internet connections, which we didn't have in the 80s, to make this somewhat useful. The second one is, how do you run that? It's kind of obvious that there's a non-zero cost and risk for operating such infrastructure. So how do you get paid for it, right? If it's all anonymous, credit card payments and so on are kind of hard. So we were baking in here an incentive layer that has I think, pretty interesting properties. So the difficulty is we want to incentivize node operators in a way that is A, cheat-proof, and B, does not destroy the privacy that we set out to establish. That would kind of be stupid if, for example, in a naive way, Alejandro is sending a packet to Betty, Betty is receiving a payment, then she's sending it to the next downstream node, Chao is immediately receiving a payment. That would reveal the route in real time, right? So that is the naive approach, which we're not doing. So what we're doing here is, first of all, we tie the payment closely to the packet relaying. So only after you have relayed a data packet and the next downstream node has validated the data packet is correct, the integrity is correct, they acknowledge the reception of the packet by giving you a key half. So it's a key sharing mechanism that we employ here. And this key derivation is closely tied to the packet information and the integrity of this Sphinx packet that I was briefly mentioning before. So by tightly coupling these two, we can make sure that you can only receive a payment if you have done a good job in correctly forwarding the packet to the next downstream node, and then you obtain your packet. You obtain your payment. Now, the thing that is not shown here is we also employ something that's called probabilistic payments. So these payments do not happen for every single packet. There's a chance that you have a payout, and there's a typically larger chance that you do not win. So this is somewhat similar to if you think about mining. If you're a miner, you're calculating a bunch of hashes, and only very rarely will you actually find a valid hash. And in a similar fashion, you have to relay a bunch of packets in Hopper before you find one probabilistically, which is a packet that yields you a payout. So this is what we call proof of relay. It has some characteristics of proof of work in the sense that you have to actually do a job, no hashing and kind of pointless mining, but actually forwarding data packets in this mixnet and then receive a payment. It also has some characteristics of proof of stake networks in the sense that you stake assets. In our case, that is the Hopper token, which is in a payment channel. So Hopper is not an L1. We think there's absolutely fantastic L1s out there, and we just use them. So currently we use Gnosis Chain as a pretty reliable and resilient L1. We could use the same deployment on any other EVM L1 or L2. And have this payment channel infrastructure in which people stake their tokens in order to facilitate this proof of relay with probabilistic micropayments. Cool. So with that, I'm pretty much done with my presentation, but I'm very happy to show you what we built on top of that to specifically address not just what we do at Hopper, but what we want to see built on top of that. And the first product that we are working on actively ourselves in a kind of sneak preview here for you is called RPC over Hopper, in short, RPCh. So RPCh is, as we call, the first truly private RPC provider. It's currently in free alpha right now. And if you want to check it out, yes, you can has private RPC. I'm just briefly showing it to you, rpch.net. You can try the alpha, which currently requires you to download a Docker container. So it's a little bit quirky, but that means it works with any EVM wallet on any EVM chain, which is kind of cool. So how does that work? Unsurprisingly, it also leverages the Hopper network. So you have a crypto wallet, which has a connector. So we have our SDK, that's the Docker container that I just mentioned, which is talking to an entry node. So this is kind of your trusted buddy that is your entry to this Hopper network. Data packets that in aggregation comprise your RPC request are hopping through this Hopper network, hitting an exit node, which is actually doing the request to the RPC provider for you before they receive a response, which is then being sent through this mixnet back to you in a privacy respecting fashion. So the RPC provider only sees the IP address of this exit node, but not you. And in fact, the exit node also doesn't see your IP address. The exit node only sees the previous relayers, like Hopper node's IP address. So the trust assumption of that one is that if there's one honest node in this relay chain, only one, then you are fine, and nobody can find out what services you were consuming here. So that's what we're building on top of the Hopper network as a specific product to address the privacy needs that I was pointing out in this derp example before. And yeah, with that, I'm happy to take questions if you guys have any questions or discussion points.
Yeah. If anybody has any questions, I think Dave just posted a question over in chat. So if anybody else has questions, feel free to post it inside the chat within Zoom.
Oh, it's in the chat within Zoom.
Yeah, you can see it there.
Yeah. So what info does the entry node see? Dave, very great question. So the entry node has access to metadata. So the entry node sees my IP address. The entry node sees how many packets I am relaying via that very entry node, but they don't see the actual data. So the entry node does not see the plain text request because that one is end-to-end encrypted for the exit node. So entry node sees metadata, exit node sees plaintext data, but no metadata. So that's why these two are separate. And actually, to make it a bit better, RPCh is not sending every request via the same entry and exit node. You can have like a large number of entry and exit nodes that are used in parallel. So you can imagine it a little bit like you're having a VPN and you're switching servers like super rapidly. So you could even send every individual packet that comprise a single request via multiple different entry nodes. Of course, the exit node has to be the same because the exit node has to glue all these individual packets together again to send out on a request to make sense. And that would provide even more metadata resilience on the entry node. I hope that answers your question.
Awesome. I had a quick question, and this is more from kind of just, I think it's just interesting to know if you had any, I guess, real life horror stories from issues within privacy from RPC providers or adversarial attacks you could kind of illustrate to make things a bit more concrete, whether it's like spear phishing or social engineering attacks or mempool related. I think that'd be interesting to hear about.
So yeah, I mean, spear phishing is a serious issue, right? And I mean, impersonation attempts are getting worse and worse. So I don't want to be subject to that. Still, I think we're relatively okay on that front because luckily, and that sounds really weird coming from me, but luckily, RPC providers are still centralized. So I want to pave way for a future of decentralized technologies that are safe. Luckily, these RPC providers and the folks working on them have not yet managed to fully decentralize everything for many different reasons that I don't all know. But I want to pave way for a future where decentralized technologies are safe for all of us to use. It would be absolutely horrifying, if it turned out that, for example, graph node operators or pocket node operators or IPFS node operators were to data harvest everything that's going on in the Web3, right? So, and try to front run the mempool because I'm 100% certain that searchers will use whatever information they have available to make more money, right? So searchers are going to great lengths today to make money. And with more access to permissionless infrastructure, I can totally see that searchers will run an IPFS or a bunch of IPFS nodes. Why? Because in a truly decentralized world where you would access dApps via IPFS, right? I would see like what IPFS does. It does this cat-millia search, right? So it does like a query in this decentralized network. And if I have a bunch of nodes running, I see that you are trying to access the decentralized version of, let's say, IPFS, right? Fast forward, IPFS would be using the graph to show pool information. I would see, oh, my victim is coming online. I would basically launch a bunch of graph nodes to kind of surround you, not with an intent to eclipse you, but with an intent to find out what exactly you're going to do. So I would be using the graph to find out, okay, what pool information are you actually querying exactly? So, and then in the next step, I might use, pocket node infrastructure to try to find your request before it hits the mempool. So all this information allow me to data harvest you, and which I find like really scary. And the primary identifier in all of that is like people talk a lot about, identifiers and IDs and so on. The primary identifier in the Web3 that's actually decentralized is going to be your IP address. And we want to prevent that from happening and make it safe for you.
Awesome. Yeah, thank you for the response. Anybody else has anything, please feel free to unmute or drop something in the chat. We'll give it a little bit of time.
Feel free to connect with us. Otherwise, also obviously on Twitter or on Telegram or Discord. I'm very interested in the interface of security and privacy. Lots of things that on a high level seem to be not so relevant privacy issues many times do lead to pretty serious security implications.
Yeah.
So if anybody wants to chat about that, that's something that we at HOPR are generally interested in. Just like a very short micro excursion, we looked at privacy concerns of Ethereum validators last year. And it's been long known that Ethereum validators are not private. Now, what it turned out is you can basically knock out a validator with a highly targeted, extremely short-term attack. I only need to take you offline for actually 4 seconds, so you will barely notice it. And during these 4 seconds, you miss a block. If I'm the next block producer right after you, all these high-value transaction and MEV rolls over to me, and I can kind of knock you out for, for fun and money. And if you are looking into the numbers, how extremely cheap malicious botnet attack, especially against home stakers, is, that's pretty bad. So again, nothing new on the one hand, only a privacy concern. If you look a little bit deeper, pretty severe security implications that come out of it, which are unsolved this far.
Yeah, absolutely. And we're looking forward to posting this online as well as internally once the recording is released. And I'm sure we'll have some cool conversations that follow. There is one more additional question in the chat. Rake is asking, because he arrived a little bit late, he's asking for use cases within private messaging. If you could kind of elucidate a little bit there.
Yes. Yeah. So HOPR is general purpose infrastructure, and you can use it for anything. So the use case that I presented in the end was RPC over HOPR. So you can use HOPR for running a private RPC provider, but absolutely you can use it for private messaging. For just toying around, we have actually built a chat app on top of HOPR that we call MindChat. MYNE chat, and MindChat is kind of a template, boilerplate chat application built on top of HOPR. Yes, you can do that. That's the hacky way. The long-term answer that I'm looking forward to is to integrate HOPR more easily, not just via our REST API that we have right now. We would be looking into providing a libp2b transport module that you can use in whatever you're using, whether it's messaging, IoT, whatever it happens to be. Cool. I don't know if there's more questions anywhere else. All right, I guess not. Yeah, all right. So thank you so much for hosting me here. And yeah, thanks for giving the stage to privacy. And please think about privacy implications as you decentralize the world. Decentralization is great, but decentralization and privacy together is the only way for the Web3 to fulfill its purpose of providing resilience to humans.
Yep.
And
Absolutely. Thank you so much again. Sorry, I just realized again I was on mute. I was trying to close you out, so I appreciate you doing it. Thank you so much again, Sebastian, for your time. It was a fantastic talk, and yeah, we look forward to conversing on in the future.
Thank you so much. All the best to the whole Spearbit community.
Yeah, absolutely. Likewise at HOPR. Take care.
Bye-bye.